Hey guys, so welcome to Unit 1 of Algebra 2, which is sequences and series. Now, when you were in Algebra 1, you did learn a little bit about sequences towards the end of the year in May, and we briefly looked at arithmetic and geometric sequences and kind of like the patterns that they make. So today we're going to look further into it, and we're going to learn a lot more about sequences over the course of this unit. So today, lesson 1 is comparing and contrasting arithmetic and geometric sequences. Now, just so you know, right, this word looks like arithmetic, but when we're talking about sequences, we say arithmetic. That's the way to pronounce it. All right. All right, so how do we compare and contrast arithmetic and geometric sequences is our aim. So firstly, let's look at these three sequences. Now, we've got a mild, medium, and a spicy sequence. And it says to find the next three numbers. So let's see. So first of all, some things I notice is that, all right, these sequences just look like lists of numbers. And that's exactly what sequences are. They're just a list, but it's a list that has a pattern. Okay? So let's look at this first one. All right, we got 3, 7, 11, 15. So it doesn't look like any of these numbers are multiples of 3, so I don't think that there's a multiplication pattern. But so let's see, how far is 3 from 7? Well, that would be plus 4. Let's see if that stays consistent. 7 plus 4 is 11, great. And then 11 plus 4 is 15. So this pattern is that we're adding 4 each time. So if we keep it going, we would get 19, 23, and then 27. Okay? So we're adding 4 for that one. Let's see the next one. So for the next one, 3, 12, 48, 192. So something I noticed right away is that it's going a lot faster than the last one. So maybe it's multiplying this time. So let's see. These do look like multiples of 3. So let's see. 3 times 4 would be 12. Let's see if it keeps going. 12 times 4 is 48. And 48 times 4 is 192. Now I got to get my calculator. Let's see. 192 times 4 is 768. Times 4 again is, hold on, I think I typed something wrong. Oh no, I didn't. Okay. So times 4 is, let's see, 3,072. And then times 4 is 12,288. Okay, great. So this is multiplied by 4. Now let's look at this last one. So for this one, there's a couple of things I notice. So first thing I notice is that the signs are alternating. You guys see that? It's going from positive to negative to positive to negative. Now, if I'm consistently adding a number or subtracting a number, it's not going to do that. Either it's going to go into the positives or into the negatives and stay there. It's not going to flip back and forth. So I know I must be multiplying or dividing. So let's see. I've got 0.625. I go to 1.25. Now, ignoring the sign, 1.25 is bigger. So let's see what it might be multiplying by. Maybe by 2. So 0.625 times 2 is 1.25. But it changed signs. So that means I have to multiply by negative 2. That makes sense? And let's see if that keeps working. Negative 2 is 2.5. Negative 2 would be negative 5. And then if we keep it going, we would go to positive 10, negative 20, positive 40. All right, so this one was multiplying by negative 2. All right. So let's see. So these are different kinds of sequences, and they're going to fall into the arithmetic and geometric categories. So this is our criteria for success for today. All right. Moving on. So let's compare and contrast these two sequences below. Some similarities and differences between them. So let's see. Obviously, I'm doing this by myself. So, all right. So one thing I see that's in common is that they both start with 3. Okay. They start with 3, and they're increasing, and they're positive. Now this one, though, seems like it's adding 2. This one is multiply by 2. So they're both changing by 2, right? 2 is involved in their change, but one is an add and one is a multiply. Now, another person last year, I'll reference what people said last year, said that this one was odd. All the numbers were odd. Here we had, it started with odd, but then became even. So it was a combination of odd and even. All right, and now another major difference between them is that this one is arithmetic. All right, so this one with addition is arithmetic. This one with multiplication is going to be geometric. Okay, so let's talk about arithmetic and geometric. So, an arithmetic sequence is a sequence that increases or decreases, okay, by adding or subtracting the same number to get to the next term. And we call that number the common difference. And it's labeled with the letter D. Okay? So D is the common difference. Kind of similar to like a constant rate of change, right? So let's look at this one. We've got 13, 12.5, 12, 11.5, 11, 10.5. So some things I can see is that this is decreasing, right? It's decreasing. And it looks like it's decreasing by 0.5 each time. It's like minus 0.5. Okay. So now let's talk about term and position. All right, so with a sequence, now a sequence can also be labeled with notation, right? So the notation for a sequence is we say that this first term here is called the A1. It's the A1 term. It's in the A1 spot. And that would be like the first position. All right, so it's the A1 term in the first position in the list for this sequence. So then the next one is going to be the A2 term, which is in the second position. So then A3 is the third. This is A4, which is the fourth one. 11 here is A5, which is the fifth term. 10.5 would be A6, which is the sixth term. And if we keep going, right, eventually we're going to get to some AN, right? N meaning any number, right? Like I could say find the 100th, right? Then N would be 100. if I'm looking for the 100th term in the list. Okay? Now, if you notice, as we go from one to the next, these little numbers at the bottom, so A1, A2, the 1, the 2, the 3, those are called subscripts. Subscript. And you see how the subscript has no correlation with the number it represents, right? So here the A3 term is 12, okay? What it does correlate to is the position, right? It's telling you it's in the 3rd position, okay? And as I move, I see that if I go forward, the subscript goes up by 1. If I go backwards, the subscript is going down by 1. So if I'm looking for some random, whoops, I switched pages by accident. Going back. If I'm looking for some random number in the list, right? Like I said, the 100th or the 30th, whatever. That's my AN. The one before it would be the A subscript N minus 1. That makes sense? Because look, like if I'm at A6, then before it is 6 minus 1, which is 5, right? And then after it would be 6 plus 1, which is 7. So the one that comes after AN is the AN plus 1 term. And then if we keep going, it would be AN plus 2, AN plus 3, etc. All right, so how to find the common difference, right? So when I looked at this, I was like, oh, it's minus 0.5. But if you can't figure that out, then you're going to use this little formula for common difference, which is to subtract a term from the one that's right after it, or subtract the previous term from the one right after. So what do I mean by that? So it's saying take an AN, any one in the list, any one. So let's say I'm going to take 11, all right? I'm going to pick 11. So 11 is my AN. And then from that, I'm going to subtract the AN minus 1. That means I'm taking the one before it. So if this is my term, this is the term before in the list. So the one before 11 is 11.5. So I'm going to subtract 11.5 from it. And when I do that, I get negative 0.5. Okay? Now, if I'm going to take a term and subtract the one before it, that means when I'm making this calculation, I cannot choose the first one, right? Because look, if I choose the first one, 13 minus what? I don't know. We don't know what was before 13. We would have to figure that out. So let's just take another pair to confirm. So D equals, let's take another 2. You always want to make sure it's the common difference and it's staying consistent and the same. So how about I do 12 and 12.5? So I do 12.5 minus, ooh, now look how I set this up. I wrote 12.5. I actually wrote it by accident, but it's okay because we can actually work with this. If 12.5 is my AN, I need to put the one before it next. So that would be minus 13. So I actually have to use the 12.5 and 13. This is my AN, and this is my AN minus 1. Because this is the second term, and this is the first. So we're doing second minus first. And again, I get negative 0.5 as my common difference. Okay? So now let's talk about geometric. So geometric sequences, in contrast to arithmetic, are now increasing and decreasing by multiplying or dividing, okay, by the same number. And we call this number the common ratio R, okay? So now not common difference, but common ratio. All right, so let's look at this example. So we got 3 to 9 to 27 to 81. That looks like I am multiplying by 3. All right. So now if I were to say, what number is in the A4 position? Which number is A4? Well, I would go 1, 2, 3, 4. 81 is my A4. It's in the 4th position. I say, what's A1? Well, 3 is A1 because it's in the 1st spot. All right. So then my A2 is 9, A3 is 27, etc. If I said, what's A10? Well, we don't know yet. I don't know yet. Right? We got to find out some more stuff about this sequence in order to figure out what A10 is. All right, so to find the common ratio, R, we're going to divide a term by the one right before it. So we're still taking this AN and an AN minus 1. So I'm going to pick two numbers from our sequence that are right next to each other. So let's say I pick this A5. So I'm choosing to do R equals A5 divided by A5 minus 1, which would be A5 divided by A4. That makes sense? And the A4 is the 81. So I'm just going to write it over this way. That's going to be 243 divided by 81. And if I plug that in my calculator, I get 3. And I want to just double check it. So now I want to take another combo of numbers. So I'm going to take 81 and 27. So I'm just going to double check. 81 divided by 27. Again, I get 3. Great. That means it's common, right? It's staying consistent. It's not changing, no matter what two consecutive terms I pick. All right. So let's see. Let's practice real quick with these two examples. So first one is find the common difference of the arithmetic sequence. So we already have a clue because it says common difference in arithmetic. So we know we're looking for D. So D is AN minus AN minus 1. So remember, you can't start by picking the first one because there's nothing before it. So we could do negative 11 minus negative 5. Now, keep, change, change. I end up with negative 6. And I want to double check it by doing the next two. Negative 17 minus negative 11. Keep, change, change. Again, I get negative 6. Okay? Next one is find the common ratio of this geometric. So we're looking for R. So I know I need AN divided by AN minus 1. All right, so I'm going to pick the second one, 120, and divide it by the first one, 20. It's 6. Let's make sure it stays the same, even if I do the third one divided by the second one. And I do. Great. So we get that the common ratio is 6. All right, you guys, so now remember we said like we wanted to find what A10 was, right? Like the 10th term. Well, we're going to learn that in the next lesson.